Hello everyone, this is Heading Tian. In this video, let's learn 3.6 polynomial and rational inequalities. Before we jump into 3.6, let's do a little bit review. If I have a function f of x equals x squared minus 7x plus 10, how to graph this function? First, we need to decide the behavior on the right and left end. First, we decide the right end. The leading coefficient is positive. So when we are graphing it, positive means going up. And then second, look at the power or look at the degree of the polynomial is even. That means we are having another side. All right, another side. The right side is also has the same behavior, point to the ceiling. And second step, we are looking for 2x-intercept. For this one, we have 2. For other polynomials, we can have maybe more or less. So let's find the x-intercept. X-intercept make the f of x equal to 0. X squared minus 7x plus 10 equal to 0. Factor this polynomial. We can use AM method. Here's A, here's M. M means find 2 factors. The addition make a -7, multiplication make a 10. They are both negative, -2 and -5. Then addition -7, multiplication positive 10. So x minus 2 times x minus 5 equals 0. X minus 2 equals 0. X minus 5 equals 0. Solve these two equation. X equals 2, x equals 5. So plot them on the graph. Here is 2, here is 5. So what is multiplicity after factoring this polynomial? Multiplicity is the power of each factor. Here is 1, here is 1. So k is 1, k also 1. K is odd number means go cross. K is odd number means go cross. So we are having the graph is go cross the point 2. And then at the 5, cross 5. All right, we're having a graph of the function f. Now I'm asking you when the f of x is greater than 0. That means I'm looking for x squared minus 7x minus 10 is greater than 0. And what is the interval notation of the x, or what is the domain of the x? So look at the graph. Which part f of x is greater than 0? Here, right? And another side f of x is greater than 0. So what is the x interval of these two parts? I can write the x interval is from -infinity to 2, union 5 to infinity. Let's see, we already spent a lot of time on graphing it and decide what is the interval of these inequalities. So how about now, I use a new method and then I find the interval of the x that satisfies this inequalities. So let's learn a new method, solving polynomial inequalities. So first we see these two, they are all polynomial inequalities. And then let's see this example. So this example, they provide us a polynomial is greater than 0. First, they plot the graph. If the polynomial is greater than 0 means all the y's value is greater than 0. So the blue part, the blue curve represents all the y's value is greater than 0. And what is the x value? the x value is from -infinity to 2. Then union 5 to infinity. Oh, that's what we have solved before. So if we are using new method, first step, we find the x-intercept first. So we need to factor it first. We have learned using the AM method. You can pause the video, factor this polynomial. We're having x minus 2 times x minus 5 equals 0, and solve two equations, x minus 2 equal to 0, x minus 5 equal to 0. We got x equals 2, x equals 5. We got 2 points. Now I plot the two positive 2 and positive 5. So we plot these 2 points on the number line without having the graph here. So we don't have this need to have this part. We just need to plot these 2 key points on the number line. One is 2, another one is 5. And then we test some point. I pick a point here. For example, x equals 0. So if the x equal to 0, make this polynomial greater than or greater than 0. So I can pick this interval. Let's plug in the x in the polynomial. X squared, 0 squared, minus 7 times 0 plus 10. What is that? That's 0 plus 10. That's 10. Can I say it's greater than 0? So look at here. Yes, it is, because 10 is always greater than or equal, greater than 0. So true. I can highlight this area. So I highlight this area. And 2 is not my solution because x equals 2. Make the polynomial equal to 0. So I cannot have 2. And how about some number between 2 and 5? For example, x equals 3. 3 squared. 3 squared minus 7 times 3 plus 10. So 3 squared is 9. 9 minus 21 plus 10. What is that? Am I right? So 3 squared is 9. 9 minus 21 and plus 10. That's 19 minus 21. That's -2. Is that greater than 0? False. All right. How about so I cannot choose the interval between 2 and 5. How about choose x equals 6? Okay, so 6 squared minus 7 times 6 plus 10. What is that? 36 minus 42 plus 10, which is 4. 4 is greater than 0. Yes, it is true. So I can highlight this area from 5, pretty 5, to infinity. Then I can rewrite the interval notation from -infinity to 2, union from 5 to infinity. And look at the graph, you will see that any x value here make the y's value greater than 0, and any x value I plug it in the polynomial, y's value is greater than 0. That means I can pick any point here. I can pick any point here that satisfies the inequality is greater than or equal to 0. But at the bottom part, here, any point I put it into the polynomial will not make the inequality greater than 0. That means it failed. I cannot choose the x value is between 2 and 5. So we can use this method. First, factor the polynomial. Second, find the x-intercept. And then by finding the intercept, all the number line has been divided into several parts. We choose one point from these intervals. So we try to see which one make the inequality greater than 0 or less than 0. Or if there is equal sign, just satisfy that inequality, make the inequality true. All right, let's see next one. We don't need to graph it because graphing it wastes us a lot of time. So first we make sure that we have a polynomial and greater than or equal to 0 or less than or equal to 0. If it is not less than or equal to 0 or greater than or equal to 0, we need to make sure the right hand is 0. So let's see this question, the right hand side is not 0. We minus 1 both sides, x squared minus 1 less than or equal to 0. Now this is a polynomial less than or equal to 0. We can find the x-intercept. Can you factor this polynomial? Is this a conjugate formula? X squared minus 1 squared less than or equal to 0. Yes, it is. That's x plus 1 times x minus 1 less than or equal to 0. Then solve this inequality or find the x-intercept. X plus 1 equal to 0. X minus 1 equal to 0. So minus 1 both sides, x equals -1. This is x-intercept. You can put some notations. And then another equation, x equals 1. Let's plot the points here. One is -1, another one is +1. Let's pick some point in these three intervals. So how about x equals -2? And then plug in the -2 in this inequalities. We have -2 squared minus 1 equals 4 minus 1. That's 3. Is that less than or equal to 0? No, 3 is greater than 0, so false. How about between? So we cannot choose here, but how about between -1 and 1? I'm choosing x equals 0. 0 squared minus 1 equals -1. Can I say it's less than or equal to 0? Yes, it is. Or we can put to 2 or yes. I can highlight the area between -1 and 1. I'm using bracket. Do you know why? Because in the question, we're having less than or equal to. So -1 and 1, they are included in the solution. And how about pick a point in last interval? So pick some point here. I'm picking x equals 2. -2, oh, sorry, +2. 2 squared minus 1 is 4 minus 1. Is that 3? Yes. Is that less than or equal to 0? No, false. So we say no. We only highlight the interval between -1 and 1. So the interval notation is -1, 1 brackets. All right, let's see next example. So first we need to find the x-intercept. We say looking for x-intercept. We can set the equation equal to, we can set the polynomial equal to 0. X squared minus 6x plus 9 equal to 0. Is this a perfect square? Yes, it is. So we can use perfect square, or you say I'm using AM method. Yes, you can do that. M is 9, finding two factors of 9, addition make a -6, both of them -3. we have x minus 3 times x minus 3. That's x minus 3 squared. So we can only just solve the one factor equal to 0, x equals 3. We only have one key number, which is 3. We don't need to plot a lot of point there because I'm looking for a point here, and put it in the polynomial to see if make the polynomial less than 0. So let's try x equals, for example, I said 0. 0 is here. Okay. 0 squared minus 6 times 0 plus 9 is 9. Is that less than 0? No, it's false. How about x equals 4? A point here. So let's see. 4 squared minus 6 times 4 plus 9. That's 16 minus 24 plus 9. We have 25 minus 24 is positive 1. Is that less than 0? No, false. So none of the number on the number line satisfy this condition. Why? You can use the method we have learned before. So first, if we're drawing this polynomial, the leading coefficient is 1, is positive. So the behavior on the right is going up. And then the degree is even. The behavior on the left is also going up. And then we have one x-intercept, which is 3. And then, so here you see, you can convert it to the x minus 3 squared equal to 0. When x equals 3, k is 2. So k is 2 is what? It's even. Even means what? Means touch and bounce off. So at the point 3, we are having the graph touch and bounce off. Okay, for example, this is a graph. And look at the graph. All the function is above the x-axis, or at least there is a touch. There's 1 point at y's value equals 0. That means if I want to have this polynomial less than 0, no, there is no x can satisfy this condition. So that means there's that's the empty set. There's no x value satisfy this condition, because we also tried these 2 points on either side of the key number 3, and both of them failed. That means that's the empty set. You can also try to graph it and see if we're having any interval, so any x satisfied this inequality. And for example, if in the future you are having this, if you have equal to 0, so we only have 1 point, x equals 3, make this polynomial equal to 0. So if in this condition we only have one solution, x equals 3. But this one is different. All right. Let's move on to see number 23. Are they all on one side of the equation? Yes, they are, because the right side is 0. And how to factor it and find the x-intercept? We know that looking for the x-intercept, we need to factor it. Factor it, what can you factor out? I'm factoring out the negative x. So the leftover is x plus, okay, minus 1, because I factor out negative x from positive x. I have negative 1 left. Then we make it equal to 0 because I'm looking for x-intercept. Negative x equal to 0, x minus 1 equal to 0, x equal to 1. Sorry, why I'm saying 1. So both sides divided by negative 1. 0 divided by -1 is 0. And add 1 here, x equals +1. We have two numbers, 1 and 0, or 0 and 1. So let's test some point. For example, from the first interval here, x equals -1. -1, I can plug it into, okay, sorry. The equations here. Okay, x -1 squared plus -1. What is that? It's -1 minus 1 is 0. Okay. Let's see. No, not 0. I'm thinking y is 0. It's -2. Yay, I didn't make a mistake. So is that greater than or equal to 0? No, false, because it's a negative number. And how about some number between 0 and 1? We can put some notes here. No. Okay, how about x equals 1/2 or 0.5? Because this is the point between 0 and 1. Okay. Let's plug it into the polynomial. -1/2 squared plus 1/2 is -1/4 plus 1/2. And -1/4 plus 1/2, they don't have the same denominator. They must have the same bottom LCD, which is 4. So multiply 2/2 on the second element. -1/4 plus 2/4, which is +1/4. Is that the solution greater than or equal to 0? Yes. That means I can highlight the number between 0 and 1. Why I'm using brackets? Because in the inequalities, we have equal sign. So these 2 points must be included in the interval. Okay, let's try another point here. Let's change the notation here. Yes. How about x equals 2? -2 squared plus 2 is -4 plus 2 is -2. Is that greater than or equal to 0? No, it's false. We change the notation here. This is no. We only have one part interval is between 0 and 1. All right, let's see next example. This is a hard one because you see the example, more terms. So how to factor this polynomial and then find the x-intercept. If we have 4 terms, we use group factoring, first 2, last 2's. First 2, what is the GCF? X squared. Left over is x plus 1. Last 2, I can factor out -4. We have x plus 1. Let the polynomial equal to 0 because we're looking for x-intercept. Factor out the x plus 1. We have x squared minus 4 equal to 0. Is that the end? No, because the second part, this factor is conjugate formula. That's x squared minus 2 squared. I can break it down into x plus 2 times x minus 2. Then I can find 3 x-intercept. First factor equal to 0. Second factor equal to 0. Last factor equal to 0. Solve these 3 equations. -1, x equals -1, -2, x equals -2, +2, +2, x equals +2. We have 3 key points. So let's plot them. And you see this is less than or equal to. So these 3 points, they are all solid dots. -2, -1, +2. So we need to find key numbers from these 4 intervals. So let's try. Maybe first one, I can try x equals -3. Put it into the polynomial here. Or if you like, you can plug it into the factored form. Yeah, maybe factored form easier because I can factor the polynomial. All right, if I don't put it into the factored form, I just bring it back to the polynomial. We have -3 cubed plus -3 squared minus 4 times -3 minus 4. Let's try. Let's see if it's negative or less than or equal to 0. We have -27 plus 9 plus 12 minus 4. What is that? That is 18, -18 plus 12 minus 4. It must be negative because negative, more negative, plus 12 still be negative. Yes, it is less than or equal to 0. Yes, you can also put 2. Second, find the number between -2 and -1. I can choose x equals -1.5. You can also say -3/2. So -1.5 cubed plus -1.5 squared minus 4 times -1.5 plus, oh, sorry, minus 4. Okay, what is that? We can use calculator and then help us. Let's see. Okay, let me use my cheat sheet, see if it's positive or negative. Okay, so it's negative or positive. Oh, it's positive. So let's put the positive. Positive less than or equal to 0? No, it's false. And then let's try number 3. So pick a number between -1 and 2. So in the third interval, I'm picking 0 because 0 is easier. X equal to 0. So here we have 0 cubed plus 0 squared minus 4 times 0 minus 4. I love zeros. Okay. I'm having 0 minus 0, 0, 0 minus 4. Minus 4, is minus 4 less than or equal to 0? No. Oh, yes, it is. Yes. So let's rewrite the notation here. The first interval is yes. Second, no. Third, yes. And the last one. So last one, let's try to plug the number into the factored form here. Make things easier. So I'm choosing x equals 3 because 3 is greater than 2. So let's use this factored form. X plus 1 is 3 plus 1 times 3 plus 2 times 3 minus 2. Let's see if less than or equal to 0. So 3 plus 1 positive, 3 plus 2 multiplied by another positive. 3 minus 2 is another positive. Yes, it's positive because we have multiplication of 3 positive numbers. But this inequality said less than or equal to 0. No, it is not true. That's false. So the last interval, no, x doesn't satisfy this inequality. So only two intervals there, yes. So we can put the solutions here, which is from -infinity to -2, included because we have equal sign here. And then second interval, let's say union bracket -1 to 2. That's it. All right. Let's see. Next question. Next question is also the inequality of polynomial. Are all the terms on one side of the inequality sign? No. We need to make sure the right side is 0. We can minus 9x squared both sides. X cubed minus 9x squared is greater than or equal to 0. So let's factor the polynomial and find the x-intercept. X-intercept, we can factor it. The GCF is x squared. We have x minus 9 is greater than or equal to 0. Make a better 9. And then we can say first factor equal to 0 and the second factor equal to 0. Square root both sides, x equals 0 plus 9 both sides, x equals 9. We'll have two key numbers, plot them on the graph, 0 and 9. And are they all both solid points? Yes, because we have equal sign. So we must have these two key points. All right, let's pick some points in these three intervals. First, I'm picking x equals -1. So x equals -1. So let's use the factored form because factor form makes things easier. Plug it in the inequality. We have -1 squared times -1 minus 9. We have 1 times -10 is -10. Is greater than or equal to 0? No. And second, you can also put false. Second, we put pick some point between 0 and 9. X equals, maybe put 1. 1 squared times, we are still using this, times 1 minus 9 is 1 times -8, which is -8. Is greater than or equal to 0? No, false. Oh, I need to have the same thing. No. Number 3. Let's try something greater than 9. How about 10? X equals 10. So 10 squared times 10 minus 9 is 100 times 1, which is 1. Is greater than or equal to 0? Yes, it is. So we only have one part interval is from 9 to infinity, satisfy this condition, but we must be very careful on the number line. These 2 points, they are also need to be included in the solution set. That means you cannot ignore 0. Even here is no, here is no, here is yes. You cannot ignore the 0. So the interval notation is 0 in the set because it is the only one element. Union or interval is from 9 to infinity. So this question is very interesting. All right, let's move on to see the rational inequalities. Rational inequalities, they have the form like these. So on the left side is a rational expression. On the right side is a number, normally we're having 0, and then we solve it. If it's not 0, we subtract 1 both sides. Make sure the right side is 0, and then find the x-intercept and also find the vertical asymptotes. So here, solving the rational inequalities, we have one more steps. First, we find the x-intercept like the previous example. But here, we're solving the x-intercept. I'm not solving the f of x equal to 0 and then solve for the x. Because f of x equals numerator polynomial on the top, denominator polynomial on the top. If I have the f of x equal to 0, I only need to set the numerator equal to 0 and then solving for the x. Because if the bottom equal to 0, that's undefined. So we just need to solve that the top equal to 0, and then what is the x value? And second, find the excluded domain value by setting the denominator equal to 0 and solving it. We also need to find the vertical asymptotes, or we say let the bottom equal to 0. And then this is also a key number there. Separates the number line and then help us pick the number between the several key numbers. And we must be careful. This bottom equal to 0, the x value cannot be included in the solution set. So if we set d of x equal to 0, the x equals something, so this point is not included in the solution. All right, number 3, create number line and plot the value, just like what we have learned before in the polynomial inequalities. All right, let's see this example. This is a rational function, rational inequality. First, we need to find what is the x-intercept. X-intercept means n of x equal to 0. That means 3x equal to 0 divided by 3 both sides, x equal to 0. So x-intercept is 0, 0. Second, we are looking for the vertical asymptotes, means denominator equal to 0. So x plus 6 equal to 0, minus 6 both sides, x equals -6. So remember this, even we have this key point, but this one is not included in the integral notation because it will make the bottom 0, that's function undefined. So let's plot 2 key points there. Okay, we don't need to have this. So the 2 key points there, x equals 0, x equals -6. So -6 goes first because it's more negative. 0 is here. So we have 3 parts. Let's pick some points. So number 3, we pick some point, x equals, let's say -7. So -7, 3 times -7 divided by -7 plus 6 is -21 over -1 is +21. Is that less than 0? No, it's false. You can say no or false. So I cannot choose this interval. And second, I can pick x equals between -6 and 0, I can pick -1. So -3 times -1 divided by -1 plus 6. On the top is -3. The bottom is 5. So we have -3 over 5. It is negative number less than 0, yes. Or you say true, because we say false in previous one, we say true here. So let's pick a number of greater than 0, so x equals 1, +1 this time. 3 times positive 1 divided by 1 plus 6. We're having 3 over 7 is positive. Is that less than or less than 0? No, this is false. Okay, we only have yes between, no here. So we can use parentheses contain the number line between -6 and 0. We can highlight -6 and 0. -6, comma 0. All right, if you're good at drawing, because we have learned in 3.5 how to draw the graph of the of the rational function, you can also graph it. Okay, decide the xy intercepts and also find the horizontal asymptotes, vertical asymptotes, plot some points. All right, let's see next example. Interval notation of this inequality. So first, let's see what is the x-intercept. X-intercept means set the numerator, the top equal to 0, x minus 4 equal to 0, and plus 4 both sides, x equals 4. Second, find the denominator equal to 0, the x plus 3 equal to 0, minus 3 both sides, x equals -3. Now we see two key points. They are -3 and 4. You see, if there is no equal sign, so these 2 points, they are not included in my solution. So remind myself, I can use the open circle here and then try some key point. So I'm trying number 3. X equals -4. And then put the -4 in the rational inequalities. So -4 minus 4, -4 plus 3. This one equals -8 divided by -1 is +8. Is that greater than 0? Yes, it is. Yes, this is true. Second, I can choose x equals between -3 and 4. I prefer 0 because 0 makes the things computation easier. 0 minus 4, 0 plus 3. We have -4 over 3 is negative number. Is that greater than 0? No, that's false. I put no here. And other key points, x equals 5. So on the top, 5 minus 4, 5 plus 3. We have 1 over 8. Is that greater than 0? Yes, it is. That's true. So yes, I can highlight this area, and then highlight this area. So the interval notation is from -infinity, comma -3, parentheses, union 4 to infinity. All right, this is a way how we found the interval notation of the inequality. Oh, sorry, solve the x in the interval notation. All right, let's see, is that the last one? Yes, that's the last example, but very challenging. Let's see why it is challenging. Because on the right is not 0, it's +2. How to get rid of the +2? We can subtract the 2 both sides. So -2 minus 2 both sides. We have x plus 1 over x plus 3 minus 2 less than or equal to 0. So if we see this, how to combine them together, one fraction and one number, combine them into one rational number. They must have the same bottom. I can combine them. I can find what is the LCD. LCD, we only have one bottom, is x plus 3. So keep the first fraction x plus 1 over x plus 3. Second term x, so 2, I can multiply the top and bottom by x plus 3, x plus 3. Now I could have the bottom x plus 3, then combine them. X plus 1 here, x plus 3. Minus on the top, we have 2 times x plus 3 over x plus 3. Less than or equal to 0. They have the same bottom, x plus 3, x, so combine on the top, x plus 1 minus 2 times x plus 3. Then distribute the 2, negative 2. Minus 2x minus 6 over x plus 3 less than or equal to 0. Combine like terms, negative 2x, sorry, x minus 2x is negative x. Plus 1 minus 6 is minus 5. Bottom is x plus 3 less than or equal to 0. Solving this, we are looking for the x-intercept, which is negative x minus 5 equals 0. We can add x both sides because I'm isolating in the x. We are having negative 5 equals x, which means x equals negative 5. Number 2, let's see, bottom equal to 0, denominator equal to 0, x plus 3 is 0, x equals negative 3. Remember that here is not included. That means we must have open circle here. And number 3, pick some points. Let's plot the points, key points on the number line. One is negative 5, negative 5. It could be included because we have equal sign here. Okay, but the second key point is not included. Negative 3, I can use open circle, negative 3. Let's plot some point here, here, and here. So x equals negative 6. Let's see. So plug them into, oh, sorry, that's too far. Plug it into this inequality, or which one is better? I think this one is better, last one, because this is very simplified form. So plug it in this equation, inequality. If you are choosing this, so you must make sure that this x make the inequality, so or the expression less than or equal to 2. You cannot make it less than or equal to 0. Make the inequality true. So let's plug it into this inequality. So negative 6 minus 5. Negative 6 plus 3. On the top, we have positive 6 minus 5. Bottom is negative 6 plus 3, negative 3. We have 1 over negative 3 is negative 1/3. That's negative number is less than or equal to 0. Yes, it is true. And how about the number, some number between negative 5 and negative 3? I'm choosing negative 4 because negative 4 is between negative 5 and negative 3. So put it into the inequality. We have this negative 4 minus 5. Negative 4 plus 3. On the top, I have 4 minus 5. Bottom is negative 1. So we have the top is negative 1, bottom is negative 1. We have 1. Is that less than or equal to 0? No, it's false. And last interval, x equals 0, because 0 is greater than negative 3. So 0, negative 0 minus 5, 0 plus 3. We have, what is this? Is negative 5 over 3 is negative number. Negative 5 over 3. Is that less than or equal to 0? Yes, it is. Let's say true. So we can highlight the interval. So let's see, use different color. The first interval is true. I can highlight this interval. And remember, -5 is included, so I'm using a bracket. And the second is not included. Last interval is included, but 3, you see there is open circle. I cannot use brackets. So highlight this area. The interval notation is from -infinity to -5, brackets, union, parentheses, -3, infinity. All right, we're done for 3.6. Please be prepared for exam 3. Let me know if you have any question. Have a good day. Bye-bye.